Hello students, welcome to Unit 2 Notes Section 2-4. At this time you can pause the video and complete the warm-up. In the interest of saving time, I'm going to do the warm-up right now. Alright, so name angle 1 in two other ways. Angle 1 we can see is right here, so it's angle AOB or angle BOA. So angle AOB or angle BOA. Notice that this question is different than what we've had on a quiz. Different ways, these aren't different ways, these are just other ways. There would only be one different way to name angle 1, which could either be AOB or BOA. But other ways, we can name it in as many ways as we want, as long as they're legal. Having the vertex right here, angle O, being in the center of our angle. Okay, name the vertex of angle 2. The vertex is, well, I just kind of answered that. It is point O. All right, if angle 1 is congruent to angle 2, name the bisector of AOC. So if this were to occur, if angle 1 and angle 2 are congruent, what does that mean? Well, that means that they are the same measure, which means that we have this thing right here is bisecting it. And that thing right there is a ray. So this is ray OB. So we're going to say ray, we're going to say ray OB. And that's the bisector because as the angle opens up forever, right, it continues on forever and ever, so does that ray. So it can't just be point O or point B or line segment OB. It is a ray because it has to go on forever. If the measure of angle AOC equals 90 degrees and the measure of angle 1 equals 45, then find the measure of angle 2. Well, the measure of angle AOB plus the measure of angle AOC has to equal, BOC has to equal the measure of angle AOC. So therefore, if I use substitution, I'm going to say angle 1 is 4. That's weird. Why did I say that? Measure of angle 1, which is AOB. So AOC being 90. I'm gonna use substitution here. Measure of angle AOB is the same as the measure of angle 1, so 45 degrees plus the measure of angle 2, which is BOC, is equal to 90 degrees. So I'm using substitution. For the measure of angle 2, I'm putting that into BOC. The measure of angle 1, I'm putting in 45. And the measure of angle AOC is right here for the 90. All right, and I'm going to then take 45 away. And I get the measure of angle 2 is 45 degrees. And that's it. We are done. Alrighty. Oops, that's weird. If AOC is 90 degrees, if the measure, name two perpendicular rays. Well, ray OA is perpendicular to ray OC. All right, because if this is a 90-degree angle, OA and OC are perpendicular rays. Again, notice O is always starting this ray because it starts at the end point, which is point O. All right. Reasoning and algebra. So here we're going to start to get into the logic. Okay, so let's write logic here. Logic and reasoning. what you do all the time, you don't even realize you're using logic. These properties you've been using for a while now, all through pre-algebra, algebra, pre-algebra and algebra 1, and even before that. So when we have an equation and we have two things, one on the left, one on the right, and I add to both sides of my equation, that is called the addition property of equality. When I subtract, it is the subtraction property of equality. If I were to multiply both sides or divide both sides, that is the multiplication property or division property of equality. All right, so let's make sure we highlight this is what's really important. These are properties of equality. So we have to write it as a property of equality. What's really cool here is we're not going to be showing our work too much. I mean, we are, but in terms of subtracting from both sides, we're going to be writing subtraction property of equality instead of actually showing the subtracting happening. All right. This is the reflexive property of equality. So the way I think about this is if you were to flex, hopefully muscles on both sides of your body would be the same. Okay, so reflexive property I think of as being the same. So 5 equals 5 is a reflexive property. 8 equals 8. Z equals Z. This is the reflexive property. The symmetric, transitive, and substitution properties all have to be if-then statements. If something happens, then something else happens. If something happens and something happens, then something else happens, okay? And these are, this one, if I take two items, like let's say I get down to 3 equals x, then I say x equals 3. Well, I just did, whoops, I don't know why I can't do that. There we go. No. What I just did was the symmetric property. So I flipped them. I flip x and 3 around. It's the same thing with letters. Okay? A and B stand for whatever they are, as long as they're mathematically legal. Right? Transitive property. I think about this at, symmetric. So symmetry, think about like looking in a mirror. So when I hold my left hand up, it looks like I'm holding my right hand up in the mirror, but it really is my left hand that's being held up. Okay, so symmetry, it's a reflection. The transitive, I think of the word train. I know that's not how you spell train, T-R-A-I-N, but the transitive property, if you think about a train, think about A and B, like a train car. Here's train car A, here's train car B. If train car B is connected to train car C, so if A is connected to B and B is connected to C, then in theory of this train, A is connected to C. It just has B in between it. So this statement is if A equals B and B equals C, then A equals C. So for this, just think about it as a train and they're all connected. We can get crazy with this. We could do if A equals B, B equals C, C equals D, and D equals E, then A equal then A equals E. That is also a statement I can make. So this transitive property is really cool because you can include a whole bunch of things. It can go on for quite a while. And the last one is not a property of equality. So these are all of equality. And what I'm not going to make you do is write the word of equality for the last one. And the reason why, it really should be in its own box. So I'm going to put it in its own box. It is simply the substitution property. And the reason why is because you don't need to substitute on both sides of the equation. B can replace A in any equation that we have, right? So in this case, I did substitute all three items. I substituted here, here, and here. But again, I could only substitute here if I want, or substitute here. So we're just going to call this the substitution property. We don't really need the words of equality. Obviously, it would apply to both sides of an equation, but you tend to just see it as substitution property. Okay? Is it wrong to say of equality? Not really, but it just might not be happening on both sides of an equation, even though, because there might not be variables on both sides of an equation. All right? Okay, so that's that. We also have, don't forget, the distributive property. This, again, is not of equality. You can either, here for this one, A times B is AB, and A times C is AC. So this is AB plus AC. I'm sure you've done this before. You've used the distributive property many times. All right. So that's your A, B, and AC. Now you can also factor something. So this is, you might see something else here. Let's say factor. So factoring is the reverse of distribution. Factoring, remember, if you have AB plus AC, you could say that that is the same as A, B plus C. We can factor out an A from both of those. Okay. Let me use an equal sign. So again, this is a factoring property. We don't really use it. And the distributive property. Oh, I don't know if it's a property. Well, let's call it a property. Okay, so those are all equality. Substitution and distributive, we do not need to say of equality. And then this last one, these are similar to these three right here. So these three right here, but they are instead of congruence, and that's really important. You have to write of congruence if they are of congruence, because we don't know what we're talking about unless we identify if it's of equality or of congruence. So here you have, for instance, line segment AB is congruent to line segment AB, or angle A is congruent to angle A, or angle 1 is congruent to angle 1, or how about angle AOC is congruent to angle AOC? And those are all examples of the reflexive property. It seems redundant, and you're probably thinking, why do we need to use it? Well, I'll show you why we need to use it, because sometimes we introduce it back into something and then we get to use it. All right. The symmetric property is the same. It follows the same pattern. Symmetry. Think about, so remember flexing. It's the same on both sides. Okay. Symmetric is your mirror. Okay. So it's an if-then statement. So you need if and then. So if AB is congruent to CD, then CD is congruent to AB. Or if angle A is congruent to angle B, then angle B is congruent to angle A. So you get to flip them and use them how you would like to. And the last one is your train. Remember transitive property. I know that's not the word train, but think about a train. If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then line segment AB is congruent to line segment EF. And that's what we have there. Or if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. And that can go on for a while as well. Okay, sometimes you'll have if, for this one, if angle 3 is congruent to angle 5, then angle 5 is congruent to angle 3. Okay, and then for this last one, the transitive, you will see, or you know what, let me write it a little different. I'm going to write it in a linear form, because this is what you'll see most of it. You'll see that, and that is the going from one to the other. This is the symmetric property. And then here's a version of the transitive. If angle 1 is congruent to angle 3, and angle 3 is congruent to angle 5, and angle 5 is congruent to angle 7, then angle 1 is congruent to angle 7. All right, that is another way we can write. That's just like a compounded transitive. I just want to go a little bit further and show you that you can keep going and going and going with this. All right, so here's what we're going to do. We're going to justify our steps of our equation. So in this case, we know that the measure of angle AOC is 139 degrees. All right, so I know that this right here is 139 degrees. We also know that angle AOB is x and angle BOC is 2x plus 10. So let me write this equation out, but I want to be careful. I want to show you that I'm not going to write out all of the steps. I'm going to talk about what I have. So I'm going to say that the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Then I'll substitute in and I'll put x plus 2x plus 10 equals I'm getting a little crooked here. Let me try to straighten this up a little bit. X plus 2x plus 10 equals 139 degrees. Then I'm going to say 3x plus 10 equals 139 degrees. Notice I combined like terms, but I didn't really show any work for it. I'm also not going to show work for this next one. So I'm going to say that 3x equals 129 degrees. See how I'm doing the work without actually writing it out? And then I'm going to say x equals 43 degrees. Okay? Now, let me ask you, how did I get from this step to this step? And I hope you see that I divided both sides by 3. That is what we call the division property of equality. So instead of showing my work, what I need you to do for this lesson and for this unit is be able to write these out in order of how they belong. So the division property of equality. Now, notice I'm writing a conclusion. I'm not writing this up here. I'm not saying, hey, I want you to divide this to get here. I am saying I divided this to get here, and I'm concluding that I use that property. So how did I get from here to here? And I subtracted. So this is going to be the subtraction property. That's my conclusion. Property of equality. You know what? To save time, I'm just going to do that. Okay? So the subtraction property of equality. Now, again, it was a conclusion. So how did I get from here to here? I combined like terms. So I'm going to say, as a conclusion, I combined like terms. Some people use the words simplify or the word simplify. I like to explain how I'm not doing. Sorry, I'm explaining the conclusion. So I combine like terms. Simplify is just like a little bit too vague. How did you simplify? I combined. Okay, cool. How did I get from here to here? I used the substitution property. And not of equality, just property okay? And how did I get to this first step? That's the true question. You know what? That is a theorem called, and we've already talked about this, it's called the angle, well, it's a postulate, the angle addition postulate, right? Just like the segment addition postulate. So the angle addition postulate gets me that. And you know what else? My first line is all of my information. So all of my information I'm going to put right here. Measure of angle AOC, it was 139 degrees. The measure of angle AOB is X degrees. And the measure of angle BOC is equal to 2x plus 10 degrees. And that is called the given. So you did your first proof and you don't even realize it. But we start off with our given information. We then create something that we can substitute into. In this case, I'm using the angle addition postulate. Awesome. I then do the substitution. So my conclusions that I substituted using my three given pieces of information that I see here, I substituted in for each one of these items. I then combined like terms. I then took 10 away from both sides, and then I divided by 3. This is our new way of explaining what we did. It's a logical statement, and we call it a geometric proof. And we're not really using geometric proofs. A lot of ours are going to be specifically algebraic. So we're going to put most of our focus on the algebra part, but we might be using congruence here and there when we do it. Okay? So for this next one, here's another example. We have that angle LM, ray LM bisects KLN. And what that means is that these pieces right here are going to be equal. Okay? So we have, no matter where I put that, it doesn't really work. There we go. All right, so we know that they're equal. So here they wrote that KM bisects KLN. So ray LM bisects angle KLN, so that's given. These are equal to each other, so those two angles are equal to each other because they are, this is our definition of our angle bisector. All right. Then what happens? How did I get that angle MLN to become 4x? And how did I get KLM to become 4x plus 40? I used the substitution property. All right. Now, oops. All right. I just had to fix a pencil. What I don't like is that they kind of left out a lot from the given. So they're pulling this information from the given. It really should be listed there, but let's just keep going with what the textbook did. I'm now going to subtract x from both sides, 2x, sorry, from both sides. So that's going to be the subtraction property of what? Yep, of equality. Make sure you write of equality for this one. You always have to say of equality or congruence if that is how it needs to be written. Like I said, distribution property, you don't need it. And the substitution property, you don't need it. But for subtraction, you do. Addition, subtraction, multiplication, division. And then we have the division property. Whoops. Property of equality. All right. And that is our second proof. So our next problem is justifying steps in solving an equation, including, in this specific example is a line segment AC that has AB and BC as pieces of it. So the first thing I'm going to do is I'm going to make a statement that AB plus segment BC is equal to segment AC. And I'm going to write this as 2y plus 3y minus 9 equals 21. And where did I get all those numbers? Well, I got AB initially. This started off as AB, which in the diagram is 2y. And we have AC was given, oh, I meant BC is 3y minus 9. And I'll erase that. So AB plus BC equals AC. Let me just center it a little bit more in the equals. There we go. Then we have 2y plus 3y minus 9 equals 21. And then my next step, I'll write 5y minus 9 equals 21. So what I did was I combined my like terms. I'm going to add 9 to both sides, but I'm not showing the work for it. I'm only writing what I get as a result, and then y equals 6 because I divide both sides by 5. So traditionally, when I teach these, I kind of start from the last one. So I start from the last two right here. So how do I get from this step to this step? I use the division property of equality. And then how did I get, and remember, we're concluding what happened from step 1 to step 2 here. And so how did I get from here to here? Well, it looks like I added. So this was the addition property of equality. Don't forget to write of equality, property of equality, that matters. All right, how did I get from here to here? Well, I just combined like terms. And how did I get from here to here? How did I get from line segments to actual values? Well, in this case, values and variables. I use the substitution property. And how did I get from here to here? Well, there was really not much that happened other than I introduced the segment addition postulate. So I'm stating what I'm about to substitute in 2. I can't multitask. ADDITION. Segment addition postulate. And what is this? All of this? This is the given. It should be written on the other side, so I'm going to erase it from this side. So the given were those 3 items, and the conclusion were all of these items here. So yeah, it's weird. You state your given, everything they gave you should go here, and then you introduce something that you want to use, and then from there, these filter off appropriately and respectively into the items that you started with, and that was your substitution property. And then from there on, you just continue on. Okay. The next one, find. Yeah, so that's the end of that proof. So, whoops. The next proof, find AB and BC by substituting y equals 6 in the expression in the diagram above. So now I'm not actually doing a proof, but I'm just going to write in that AB equals 2y. So AB equals 2 times 6, and AB equals 12. And then I have, let's see, BC equals 3y minus 9. So BC equals 3 times 6 minus 9. BC equals 18 minus 9. So BC equals 9. And let's check that AB plus BC equals AC. And that should be rather easy to do. I lost one of my colors. I don't know where that was. Oh, weird. My favorite list. I don't know. I adjusted something incorrectly on that. Okay, so AB plus BC equals 21. So 12 plus 9 equals 21, and 21 equals 21. So that is true. All right, and for this, I could have justified each step, but that was just asking for me to check it, to check my work. So name the property of equality or congruence that justifies each statement. Here, the first thing I like to look at is whether or not this is a property of equality or congruence. So the first thing that should stand out is that it is a property of congruence. So I'm going to finish it off with property of congruence. You don't have the ability of moving items like I can, so in an effort to save time, I'm going to copy and paste. And if I'm not mistaken, A, C, and this next A are all properties of congruence, and these right here are property of equality. And you might have to pause the video after this because I'm moving much faster through this than you probably have the ability of doing with pencil and paper. So I'm thinking, you know what? I'm going to move these to be right to the right of it because it'll probably be easier than writing it below. And what are they though? So the first one is the reflexive property of congruence. So reflexive property of congruence. The next one, if 2x minus 8 equals 10, then 2x equals 18. Well, what did I do? I went from 2x minus 8 equals 10 to the next line was 2x equals 18. It appears I added 8 to both sides, so it's the addition property of equality. And I'm going to change this color. All right, the next one. Ooh, it looks kind of like a train. So this one, I'm going to have to erase this because I don't have enough room. I'm going to have to write it smaller. This one is going to be the transitive property of congruence. And again, why is it a transitive? Okay, why is it what it is? The reflexive property, remember, it's on both sides. It's like you're flexing. It's a congruence because of the congruence symbol, so it's the reflexive property of congruence. This one, if I write it this way, it's a little bit easier to see. If I have this, then I have that. Well, I added 8 to both sides, so it's the addition property of, and addition can only happen with equality, so it's property of equality. This next one, if segment RS is congruent to segment TW and segment TW is congruent to segment PQ, then RS is congruent to PQ. So those segments, why? Because the transitive property of congruence, remember the word train, it's like this car is connected to this car, and this car is connected to this car. So it's kind of like saying the first car is connected to the last car. All right. Now this one is like a mirror image, right? First you have A on this side and B on this side. Then it switches where B is on this side and A is on this side. So that is the reflexive, that's the symmetric. I'm going to do the symmetric property of equality. All right. This next one is it's just like the first one, except it's not of it is of congruence. So it's also the reflexive property of congruence. In the last one, we have measure of angle A is equal to 45, and 45 is equal to measure of angle B. Then measure of angle A equals measure of angle B. So this is a train car 1, train car 2, train car 2, train car 3, train car 1, train car 3. So this is first train's connected to second, second's connected to the third. Then in that case, first is connected to the third. So we are going to, that will work. So the transitive property of equality. All right. Some students ask me, Mr. Albernaz, why is this not substitution? If this is equal, if this happens and this happens, then this happens. Well, I guess you could say that you would substitute 45, wherever you saw 45, you would substitute in the measure of angle B. But the way this is written is very much like a transitive statement. Okay, it goes in that perfect order. Whereas if you looked at what our substitution was saying, it was saying if this equals this, then it can replace A in any expression. We don't normally use this one when listing it. Unless I say if A equals B and A equals 6, then 6 equals B. If it's out of order and it doesn't go in this beautiful order right here, then we would then say substitution. But transitive is normally the one that looks like it's in a nice put together order. So, all right, I think that was the end of the notes because it looks like we're already on the homework part, which is homework exercises notes 2-4. So you're going to do this one, and then, so we're going to do that in class, and then we're going to do practice 2-4 in class. It looks like a lot of work. It kind of is, but it will definitely take us the whole class to probably go through these and write them in. And then you have your corresponding IXL assignments, and they are now on, those assignments are Algebra 1 assignments. So just make sure when you click the link, it's connecting you to the Algebra 1 stuff, which I've already preset to do. Okay, good luck.